Welcome back to the video lecture series for Introduction to Adaptive Programming using Scala. We're continuing our discussion of Stream.io and the Java libraries for it. And here in this video we're going to start focusing on the topic of serialization. Serialization is the act of taking data, objects, and converting it to a stream of something that you can save or send, and it's, as opposed to the object in memory itself, you want something that you can either put out in a file so that you can read it in later, or you could send it across the network, or do whatever. But you're converting it. Normally we think of serialization as just converting it to a sequence of bytes. You're turning it into that sequence. So in the last video we looked at data input stream and data output stream. And one way to serialize objects would be to make it so that they have a function in them that takes an output stream and then they write the relevant data out to that output stream. And so we could certainly add code to do this. So for example, in our program, maybe we might want to have something that serializes the shapes that we had made previously. So let's go ahead and create another file here. So, and I didn't tell it to add the main, simple enough to do. So I could have this so it creates some shapes. So for example, and let's go ahead and let's make an array of shape. Shapes equals array of new circle 5 comma color.red, and we import that. Okay. So that's happy new rectangle 4,3 color dot green. Okay, so I have an array of shapes, and I want to write this out to a file, and I want to save it in some format so that I can later on read all of these shapes back in. Now we could do this by writing it to a text file. We could make it so that our different shapes have a method in them that writes out to a print writer. Since we're dealing with binary here, we could also make it so that each of these had a method that was that takes a data output stream, and actually there is a type called data output. And the data output is a supertype of the data output stream, and it just has the main methods that you would need. Whoops, and I don't want any curly braces here because in this case for the shape this would be abstract. Of course, having it abstract there means that our circle and our rectangle have errors. Oh, these were the mutable versions. And I would have to put these inside of here. So for example, the rectangle would need to write out its 3 values. We would have to do out dot write double of width, and out dot write double of height, and out dot write something for the color. The easiest way to do this for a color would be to call get RGB and just write a single int out for the color. So we could do this, and we could add our code manually to all of these things and do kind of a manual binary serialization. Then we'd also have to have code to read it in as well. And one thing that I haven't hit on here is the fact that when this code, if it were to go through and write out this array, when we read it back in, we'd have to have something in addition to the double for 5 and the int for red. We'd have to have something that tells us the first thing is a circle and the second thing is a rectangle, and then to instantiate those appropriately. Okay. That actually when you put that all together, is a fair bit of a pain to write. And so we're not going to do it that way. It turns out that Java has a feature called default serialization. And it allows you to do binary serialization of objects and do it without you having to write the entire code that we just described. Now, you don't necessarily want to do this for everything, but if you need to save something off into a file or you need to send it across the network, it turns out that that using the default serialization can be very helpful. So how do we do that? Well, instead of using a data output stream and a data input stream, there are types called an object input stream and an object output stream. So the object output stream, we create it in a similar way that we would have with the data one. We generally wrap it around some other output stream. And it has all the methods that we had before. It is a data output, so it has these methods for us, but it also has another method that we didn't have, write object. There's also a write object override. There are some details to serialization that I'm not going to get into here. But this is the one that really matters. This allows us to write any object that we want out to the object output stream. And it will automatically go through the process of converting it into binary and writing it out. There are some restrictions on here though, and we can illustrate one by trying to do this just to start with and seeing what goes wrong and what error message we get. So I'm going to create an object output stream, and I'm going to wrap that around a new buffered output stream. This is such a small amount of data, it doesn't matter much, but I want you to get into the habit of doing that. And then I'm going to wrap that around a file output stream. Shapes.bin. And import, and import. Okay. We've just opened a file. Remember to close it. And now I want to write out those shapes. Okay. So that's the code. It compiles. What happens when I try to run it? I get an error down here. Now what does this error say? It says that it's a not serializable exception, and it's inside of our example, and the last place inside of our code was right here in line 12. Wow, that was interesting. So it's this write shapes. It says something's not serializable. If you want something to be serializable, you have to tell it. You have to tell the compiler that, the environment, and the way you do that is to make it so that the type that you want to serialize extends serializable. So in the case of this, if I put extend serializable in there, now I've just told it that shape and all the subtypes of shape, because remember if a supertype inherits from something, all the subtypes get that as well. So now my circle and my rectangle are also serializable implicitly. Okay, I don't have to actually go make any modifications to that code. They will just they will automatically inherit the same serialization that the shape is inheriting. So now what happens if I run this? It ran. Okay. Okay, so let's come over here and let's refresh this, and now there's a shapes.bin. And so if I minimize things and get them out of the way, sure enough, there's a shapes.bin file. Yes. And if we look at this, it is a binary file, clearly. There are things in here that are not normally readable. If we were to do this with XSD, you can see that there are lots of codes that don't print very nicely, but you can also see things in here that are clearly readable. Little examples.shape. Okay. Hey, that's the type that we were working with. And this open bracket here implies that this is an array of little examples.shape. Little example.circle, because we wrote one circle in there. It has a radius. It is a little example.shape. There is a color. And then it's a java.awt.color. There is also a rectangle in here, which has a height and a width. Okay. Now, this is using a lot more space than if we had just written out the one double and the one int for our that we had been talking about before. So the circle gets one double and one int, and the rectangle gets two doubles and one int. But this also has sufficient information to completely reconstruct these types and to tell it what the types are, which is why there's this text in here giving the full names of the types that are involved. So if I want to be able to read this back in, I have to do the inverse part, which is to deserialize this. We want to make sure this works. So let's go ahead and say an object input stream equals new, you know what, copy, paste, uncomment, object input stream in. And import all of those. Make sure we close it. Now, let's go ahead. So let's just first say val shapes equals OIS dot read object. Shapes dot, or print line shapes, so that we can see that what we've read back in, because it should have one circle and one rectangle, and we get that. Well, it ran. Okay, that's a good sign. However, we can't tell if it actually read one circle and one rectangle, and if they had the values that we wanted in them or not. And the problem here is, once again, arrays don't print nicely. Oh, well, so normally what I would do is I would just say, since shapes is an array, I do shapes dot for each print line, and then it all works nicely. Except here it doesn't. Okay. Why doesn't this work nicely? Okay, well, the problem that we have here is that shapes is not an array. It's an object, which in Scala is the equivalent of an anyref. Okay, it's this broad, vague type, because when we call read object, this code doesn't know what type it should be reading. It just knows it's going to read an object. Okay? So it could read any type of object for us. And the appropriate way there are ways of just casting it and saying, oh, well, it's clearly an array of shape. That is not considered the good way of doing things in Scala. Instead, we're going to put a match here. And one case is going to be that it is an array of shape. And so if we get an array of shape, then I'm just going to give back that ARR. If I get anything else, though, well, that's a problem. So I want to, in this case, I'm going to throw an exception. So it turns out if I put in like 0 here, that causes problems, because now this is of type shapes is of type any, because it needs to pick a type that is both an array and an int. And the only super type that'll do that is any. Throw new I really should have an exception that matches this, but I don't feel like going to look for something in the libraries that's quite appropriate. An illegal argument exception or an illegal value exception. If there wasn't one, we could create one of our own, but I don't want to spend the time doing that right now. And now you'll note that the for each works here, because now shapes is an array. Interesting thing, you might ask, well, okay, so this didn't work when this was a 0 because the type inference had an int here and an array of shape here, and that the only common supertype of that was any. What is this? Well, when you throw an exception, when you create your own exception, this is returning type nothing. And if you go back and you look at the inheritance hierarchy in Scala, there's the figures in the book that show you this. Nothing is a common subtype of every possible type. And so this actually does exactly what we want for the type inference. Because this is this gives you back a nothing, well, the common supertype of nothing and an array is an array, because nothing is a subtype of array as well. And so that compiles nicely, and when we run it, we have a circle and a rectangle. How would I make it so that I could tell that these were actually doing what I want to? I could give them two string methods. And so this would be a circle plus radius plus, I'll just put okay, let's go back. Is there, it's a private val. Okay, so the only way to access this would be there. Copy. I want to do basically the same type of thing inside of my rectangle, except, oops, apparently I can't spell circle. Because it's in a string, Scala doesn't care. Width plus height plus the color. So now if we come back to our serialization, we can verify. Oh, ooh, that's a fun one. Okay. This ran into the problem that it says the type is incompatible. And this is another challenge with serialization. By default, pretty much every time, so your objects have what's called a serial version UID in them, which is a unique identifier that tells it basically what compiled version of the code you were working with. So if I save these objects as one version and then I read them and it gets a different version, it says no, 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 these aren't compatible. Now, if you intend to write things out to file and have them stay there for a long time, you need to deal with this. And the what you can do is you can set your own serial version UID, and that will make it so that you have control over that, and then you only change it when you actually change something big in the class. We can verify that this just rewrote another version of shapes, and if we come over here, once again we comment the first half and uncomment the second half, and now we run it, and it manages to read in a circle and a rectangle. This is a 5, this is a 4 and a 3. The circle has red totally on, and the rectangle has green totally on. So it is managing to read in these objects, and the default serialization works. You've already seen that there are some challenges here. Things like the serial version UID changing pretty much every time that you make a change and recompile the code. It's not quite that bad, but it turns out even if you add a method that doesn't add data, that new method will change the serial version UID. So that's something that you have to keep in mind, and there are some other issues, and we'll come back in the next video and we'll talk about the issues surrounding default serialization.